Welcome everyone to today's webinar with Sitting Victoria. My name is Anna Pimenta and I am the Landcare Development Coordinator with Landcare Victoria, and we also have Tani here today from our team to help just this webinar run smoothly. We had a great interest in this webinar tonight, and it is no surprise to us as this is what landcarers do and love, native plants, right? I also take the opportunity to acknowledge all the important work that volunteers like yourselves do and contribute every day to landcare and the environment. So this webinar is a result from a partnership with Sitting Victoria and Landcare Victoria, and we are so proud of this collaboration and to be able to work with such important and inspiring organisation. Before we start today, I would also like to pay my respects to the traditional owners and custodians of the lands on which we are meeting today. Landcare Victoria recognises the ongoing role of traditional owners in caring for land, water, wildlife, and also acknowledges the deep connection that Aboriginal and Torres Strait Islanders people contribute to the country. I also would like to personally acknowledge the Gunai Kunai peoples, the land I am working on today here in Gippsland, and I pay my respects to the elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people joining us today. And before we start, I'd like to just give some housekeeping. First, please don't feel like you need to write everything down because this session is being recorded and will be available in our website, and I'll also send you a link to all registrants. Please also note that all microphones have been muted. We will be stopping after Karen's session today at the end of this webinar to answer some of the questions. So please use the Q&A button at the bottom of your screen at any time to pose a question. Some of your questions might be able to be answered by Ellie and Abby, but if your questions are for Karen, we might just get to them at the end of this webinar. So we do have also a lot to cover tonight, but if any of your questions goes unanswered or something you'd like to follow up on, please don't hesitate to get in touch. So I'll start with some introducing some of our speakers for tonight. And as I said, there's me and Tani today from Landcare Victoria. From Sitting Victoria, we have Ellie Fox. We have from the Southern Otway Landcare, we have Abby Imhoff. And from the Botanical Gardens of Sydney, Dr. Karen Somerville. She's our main speaker for tonight and has a lot to share. And with that, I'll stop talking and give the microphone to Ellie and to Abby, and I'll see you all in the other side.
Thanks, Anna. I'd like to just start off by saying I'm joining from Wadawurrung country today, and the Creswick Seed Bank is sitting on Jajawarring country, so I'd just like to acknowledge that. Today's presentation has come to fruition through our Seed Pod program, and I'd like to say thanks to our wonderful partners at Landcare Victoria for hosting this, and our newest Seed Pod partners, Southern Otway Landcare Network and Shrub Club. I'm super excited to hear Karen speaking about recalcitrant seed and how we can apply her research to our temperate species. I was mentioning before that I've been following Karen's work for some time, since 2021, and now's been the perfect opportunity and melting pot for it all to come together. And every time I hear you speak at a conference, Karen, I love it. So I'm really excited to be able to share this with people. And I'm glad to get the opportunity to listen to you and experience your expertise. Thanks. And thanks from all of us at Seeding Victoria. And I'll pass over to Abby.
Thanks, Elle. Hello, everyone. I'm Abby from the Southern Otway Landcare Network, here with our crew of a few of our Shrub Club volunteers in our nursery. Before we start, I would like to acknowledge that we are on the lands of the Eastern Ma on Gudabanud country, down here in Apollo Bay, on land that was never ceded. We're part of the Southern Otway Landcare Network, and we have a small nursery, a small community nursery here in Apollo Bay called Shrub Club, It's led by Nicole and I, and about a small team of about 30 volunteers, a couple of our main volunteers who are here today to answer some of your questions too. Our nursery is the heart and soul of what our land care network does. It's as well as growing probably 40,000 plants every year. It's an incredible space for community connection with the landscape and with each other. So we run plant walks every month to collect seed all over the Otways, and we grow plants here together, and we learn about our landscape and our Indigenous plants together. So it is a really beautiful space. We grow about 170 species. So we cover a huge area from Wye River all the way to Lavers Hill, from the coast and up to the top of the ridge of the Otway Ranges. So we cover a huge number of different EVCs and ecological vegetation classes and different plant communities, from coastal plants to heathlands to cool temperate rainforest. So it's a lot to get our heads around. And I think it was 2024, I connected with Elle, and she was just starting up the Seed Pod program with Moorabool Land Care Network. So we jumped at the chance to be part of that. And we just did our first workshop with Dan Frost at the start of this year, and we're planning to visit the seed bank soon. But it's just been an incredible resource for us to think about the ethics of collecting seed, around tracking provenance and making sure that what we're putting back into the landscape is a really well thought through decision, that we're thinking about climate adapted seed, about where seed is coming from, if it's suitable for that re-veg project. So yeah, I feel like it's been an amazing opportunity for us, not only as staff, but our whole network of volunteers, to learn all of that as well. Why we wanted to do this workshop, as I said, we collect from a number of different ecological vegetation classes, but we do, the Otways is famous for its cool temperate rainforest. It's a pretty special part of Victoria, and we are very proud to grow lots of cool temperate rainforest species, including myrtle beech and a lot of fleshy fruit species. But it's tricky because some of them, by nature, cool temperate rainforests are in deep, steep gullies, and accessing those gullies is hard work. We get covered in leeches, we get lost, we fall down, and we have a tough time, as fun as it is. But sometimes we can't get to those spots every year, and a lot of those species are recalcitrant seeds that don't want to be stored and dried out and put in the fridge. And we can't sow them the next year. We have to only collect what we can use that year. So it's really important for us to think about how we can store those seeds. And I guess in addition to that, we're thinking about our changing landscape. So in the last few years, we've had fire in the Otways in areas where there's not traditionally fire, in those wet gullies, which is really scary. And some of our species are only existing in those wet gullies, in really thin marginal areas. So we are interested in how we can collect more seed to protect those plants and have them for the future. And also our seasons are changing. Like, it's probably the same across all of Victoria, but for us here, it's unseasonably warm for the last day of April. So yeah, I think that's why it's so important for us. And we're really looking forward to Karen's presentation. Thanks, everyone.
All right, thanks, everyone. I'll just share my screen. All right. Thanks so much for joining us, everyone. And I'd just like to say it's a real pleasure to be talking to people who are so passionate about and so active in helping the environment. Thank you for what you do, and I hope you find something useful in this talk today. It's entirely possible that your experience might differ from mine. I'm perfectly happy for you to tell me if I've got something wrong and you know better, because I'm learning all the time. So just for a bit of background information, I work for the Botanic Gardens of Sydney, and that's made up of 3 botanic gardens. The one up the top there is Mount Tomah, the Blue Mountains Botanic Garden, which has cool climate plants. Then we have the beautiful old Royal Botanic Garden, Sydney, on the harbour, which has a mix of exotic and native plants. And I'm based out at the Australian Botanic Garden at Mount Annan, out near Campbelltown, which is southwest of Sydney, and we specialise in Australian native plants. So all of those sites sit on various Aboriginal country. So we have Darug country in Mount Tomah, Gadigal country in Sydney, and Dharawal country at Mount Annan. So I just like to pay my respects to all the elders and the traditional custodians of the lands that I work on. So at the Australian Botanic Garden, we have this fabulous facility called the Australian Plant Bank, and this is where I work. This is a conservation and research facility that supports both in situ and ex situ conservation. The heart of the building is a seed vault where we store seeds from as many different rainforests, Australian native species as we can get our hands on. But we also have facilities for tissue culture and adjacent nursery facilities for handling species that aren't suitable for seed banking. So the reason that seed banking is the core of ex situ conservation is because you can preserve a huge amount of diversity in a very small amount of space, and it provides insurance against extinction, and it also provides material that we can use for translocation and research. For restoration purposes, seed banking makes the most of your collection effort. So if you go out and make a great seed collection, but you can't use all of it in one season, then it's really good to be able to bank that seed and put it away to use it for the next season. It also evens out intermittent seed supply. If you've worked in rainforest much, you'll know that sometimes they set seed and sometimes they don't. And sometimes you can go for a few years between seed set. So if you can have that seed in storage to carry over those years when plants aren't producing seed, then it's really helpful. And also it helps to maintain your supply through events like fires. I was mentioning the other day to Abby that I was working with a land care group a few years ago who had just gotten a 7-year grant project, and they'd gotten into the second year of it. They had a major fire go through their remnant vegetation, and they had nowhere to collect their seed. So having a storage of seed is really useful for backup in those circumstances. So what sort of seeds can be banked? I'm sure you're familiar with these, but basically anything that can tolerate drying and freezing. So for conservation purposes, they need to be able to tolerate drying down to about 5% moisture content, and then they need to tolerate storage in a freezer at minus 20 degrees Celsius. And that actually applies to around 90% of our native plants. So they grow in naturally dry environments. They're geared up to tolerate those drier conditions and go through those periods of drought until they get rain, and then they can sprout. So those sorts of seeds have the intrinsic makeup that makes them tolerate the seed banking conditions, which are a little bit harsher than they find in the natural environment. That is really necessary for making the seeds last for as long as possible. So I've pulled this off the Shrub Club list. This is a few examples of local genera that can be banked. So all of your wattles and basically most things in the Fabaceae that produce those hard-seeded, very hard seeds with a very hard seed coat, store really well. And then things like Alocasuarina, Angophoras, Banksias, Berseria, all those things that have the dry fruit and dry seed will store quite well. The ones that's difficult to bank is anything that doesn't tolerate drying or freezing, and that can range from things like the bunya pine, which has enormous seeds and just doesn't tolerate any drying at all, to macadamias, which actually will tolerate drying, but they don't like being put in the freezer. And then things like the Davidson's plum, which doesn't tolerate drying at all. So Australian rainforest occupies less than 0.5% of the landmass, but it has a huge amount of diversity. So it's home to more than 3,500 different seed-producing plant species. And that ranges from the very complex wet tropical rainforests up in the north of Queensland, monsoon rainforests, down through to subtropical rainforests, and then as we go further south, getting into the warm temperate and cool temperate rainforests. The complexity tends to decline as you go from north to south, but you get a lot of overlap between those different rainforest types. And so even in Queensland, you can get cool temperate rainforests on the mountaintops. So one of the reasons that we're very interested, oh, that's just skipped, go back. One of the reasons that we're very interested in looking at rainforest seed storage behaviour is because it's such a huge diversity. And we've mostly focused so far on dryland species because we had a suspicion that most of the rainforest species weren't going to be amenable to banking. As far as Victoria goes, you have a mix of cool temperate, warm temperate and dry rainforests, and they occupy a relatively small area as well, but they have some really interesting diversity and they provide diverse habitats for the flora of Victoria. I don't really know that much about rainforest in Victoria, as you can tell by that little blurb there, but this was a very handy map that I got from Vic Rainforest, and they had some good descriptions of rainforest types that will feed into some slides that I'll show you later on how different rainforest species respond to banking. So because we didn't know much about how rainforest seeds would respond to banking, we started up the Rainforest Seed Conservation Project. And this had an initial phase from 2009 to 2012, and when we were just looking at species and whether they would tolerate drying. And then we extended that from 2013 and have been working on it ever since, and basically collecting from all along the coast of New South Wales up into Queensland and seeing how will these seeds germinated when they were fresh, how will they germinated after drying to 15% relative humidity, and then how well they tolerated storage at -20°C. If you'd like to see the germination conditions for the species that we've looked at so far, that link there has a PDF document that's attached to the paper that we produced on the topic, and that has all the details on the germination conditions. So just a little segue here, and looking at some of the collecting methods we use. One of the difficulties with rainforest is that you can get such tall trees, such high canopy, things way out of reach. And sometimes all we can do is collect from the ground. We've got long collecting poles, which we can use to collect from trees if the fruit is low enough within a few meters. But sometimes that's all we can do is collect from the ground. The other thing that you can do is to string nets up underneath the trees to catch the fruit as it's falling. Or you can go to extremes like they did for the Wollemi pine and dangle out of a helicopter, but I don't recommend that. Apparently you get a lot of scratches and bruises. One thing that we do quite a lot now, if we have access to plants, and this is particularly more applicable to shrubs than to trees, is that we can bag developing fruit. And that stops predation, but also helps to preserve the fruit in one place so that you can go back and collect it when it's ripe. When we go out collecting, we put a lot of effort into quality control. So we'll take a herbarium specimen of anything that we collect from. We'll collect all the data around GPS coordinates, surrounding habitat, other trees and plants that are growing in the vicinity. And most importantly, we'll do a cut test of the seed collection to make sure it's a decent collection. So for this, if you just pick 10 seeds out of your collection, cut them open with a pair of secateurs or a pair of nail clippers, and just have a look inside and make sure that it has a good seed in it, because if it's not filled, then it's pointless collecting it and it's pointless storing it. When we get the seed back, we clean it up, and then we'll do germination testing first of all to see what the initial viability is while the seed's fresh. Most of our germination experiments are done on agar in petri dishes. Some of the rainforest seeds have really big seeds. So, some of the rainforest plants have really big seeds that don't fit in a petri dish. And so the other thing we use are just these little miniature glass houses that I got from Bunnings. And we sow the seed on potting ricks, and you can put a little bit of water in the bottom of the tray with the seeds in it on top. Put the lid on the top, close all the vents, and then that keeps the humidity really high, and you can leave the seeds in there for quite a long time until they're ready to germinate. And if the seeds won't germinate, we've got a few things that we'll try, and sometimes we get a bit desperate and we try things like cracking the nuts open in a vise, which works quite well for some species that have a hard woody endocarp. Sometimes we need to remove the endocarp entirely for things like Guygerus species. And then we have things like Fabaceae species. This one here is snowwood. And that's just a scarification with either a scalpel or by clipping with what we're using at the moment is dog clippers. So other treatments might include putting them through chilling, cold stratification, or applying smoke water to the top of the agar, or putting them through seasonal temperatures. So we'll try anything. Sometimes we get, with the rainforest seeds that will take, 2, sometimes 3 years before they'll start to germinate, which is really painful, but that's just the way it goes. But we try to find different ways to get them to germinate more quickly. And one of the things that we do is just look at the seed's natural environment to work out what's the best thing to try first. So it can be quite a challenge to germinate them sometimes. So it's good to have a look at some background information if you can find it to begin with. And these are some of the references that I use a lot. The one on the left, Australian Rainforest Seeds, is a lovely book that was put out by Firewheel Nursery in northern New South Wales. And that has information on about 300 different species, when to collect, how to clean them up, and how well they germinate and how long they take to germinate. The second one is a seed information database that used to be hosted by Royal Botanic Gardens Kew and now sits on the Society for Ecological Restoration website. This one, you just type in your genus or your species and it will give you a list of anything species that they have any information on at all. We'll go into that a little bit more shortly. The next one is our own virtual seed bank, and that is contributed to by all of the major seed banks around Australia, and has information on how many seeds we have in storage and whether there's any information on how to germinate them. And one that might be particularly applicable to yourselves is the seed germination database held by the Royal Tasmanian Botanical Gardens, which has really good information on all the different methods that James Wood has tried to germinate the seeds that he collects from Tasmania. Okay, so going back to the Rainforest Seed Conservation Project. So far we've tested more than 400 species, but we didn't get germination of greater than 50% for many of those. So what I'm presenting here is for 162 species. It does represent 63 families, so it's a fairly wide diversity. And what we found was that only 22% of them were sensitive to the drying needed for banking, which was really good for us, kind of surprising. But yeah, really, really good to know that we had many more rainforest species than we thought that would be tolerant of the drying and that we could potentially bank. So 64% were fully tolerant of drying down to 5% moisture content, 10% were partially tolerant, which means they lost a little bit of viability, but overall, sorry, my slides keep going of their own accord. Overall, we had 74% of the species that we tested so far that were potentially bankable. So that was a really good outcome. And we found that the response was the response to drying was related to plant habit. So for herbs, most of the herbs were very tolerant of drying. Likewise for climbers and the shrubs. Shrubs to small trees had a little bit more desiccation sensitivity, but then you really saw the desiccation sensitivity when you got up into the tall trees. And from there, we had about 45% of the species that we tested were sensitive to desiccation, and the rest of them were okay. Some of the other easily measured seed characteristics that we found that were useful as predictors were the dry weight of the seed. So this chart on the left, you can see the brown bars give you an indication of what proportion of the seeds were desiccation tolerant, and the blue bars what proportion were desiccation sensitive. So on the left, we have the dry weight of an individual seed. And this data includes our own data from Australian rainforests, which showed the same pattern as data from Panama and China. So I've just combined all that data into one chart there. And you can see that seeds that are 20 milligrams or less in weight are most likely to be desiccation tolerant. but then as the weight of the seed goes up, then you get more proportion of the desiccation sensitivity. On the right-hand side, we're looking at seed moisture content when the seed is fresh. Anything that has a moisture content less than 20% is usually desiccation sensitive, and then the likelihood of is desiccation tolerant. The likelihood of desiccation sensitivity increases as the moisture content at maturity increases. The seed size and the shape were also useful for indicators of the drying response. So very small seeds, so again, seeds less than 20 milligrams in weight, like Ficus heniana, they were quite tolerant of drying. Seeds that had the hard seed coats, like Parachidendron pruinosum or snowwood, were tolerant of drying. And then for desiccation sensitive, if the seed is quite large and it's got a thin seed coat, it's more likely to be sensitive to drying. And interestingly, if it has a green embryo. So this picture down on the bottom right-hand side of Archidendron hendersonii, that's a species that's in the Fabaceae. So same family as you get all of your acacias and all of those hard-seeded Fabaceae species. This particular one has quite a soft seed and a green embryo inside, and that one's very desiccation sensitive. Okay, so it took a long while to get that data, and we found that none of the indicators that we came up with were useful for predicting desiccation tolerance or desiccation sensitivity uniformly across the range of everything we collected. So you had the data were useful at either extreme, so very high moisture content's going to be desiccation sensitive, very low moisture content's going to be desiccation tolerant, but then you've got that middle bit where it's quite difficult to tell whether it's going to go one way or the other. So we put all of our data into a key that also incorporates data from papers published previously by other authors. So it's fairly simple, and the first step was just to check for information on storage behaviour for other species in a genus, and then you can go through and look at the seed coat and see how hard it is, conduct an imbibition test, and so on. And each step will tell you where to go next to see how your seed's likely to respond to storage. So I just want to go through each of those steps one by one. And the first step, just check for information on other species in the genus, because genus is generally a fairly good predictor of how your species is going to respond. So here's an example here for Acacia melanoxylon. We have a look at the seed information database that's held by the Society for Ecological Restoration. And down on the right-hand side here, you can see all these cute little icons, and they tell you what they have information on. So if you've got a ruler, you've got information on size. A box means you've got information on storage. The little seedling means you've got information on how to germinate the seeds, and so on. So this is a really good site for getting information on a range of different things if it's available, and because it's being contributed to by people from all around the world, there's a fairly good chance that there'll be at least some information on a genus that you might be interested in. Okay, so if you don't get much information there that's useful, then you can just dissect the seed and see whether the seed coat's hard or soft. If it's hard, you can go to step 3, which is to check the permeability of the seed coat, and we'll go into that in a minute. And if it's soft, then you go on to step 4. On the third step, we do what's called an imbibition test and see whether the seeds can take up water. And for this, you just take 10 seeds that you leave intact, 10 seeds that you chip the seed coat for, and you put them onto something moist, so agar or moist filter paper. And then you weigh them at the start and then weigh them after, say, 1 to 3 days. And if the weight of the scarified seeds ends up being much higher than the weight of the intact seeds, then you know that the seeds have what's called physical dormancy, which means that the seed coat is impermeable and can't take up water unless it's damaged. And that also, coincidentally, means that they're desiccation tolerant, because to get to that stage of being physically dormant, they go through a natural drying process. Step 4 is just to check moisture content and dry seed weight. And all we do with that is we weigh seeds before and after drying, and we do it in an oven set to 103 degrees and dry them out for 17 hours. And you can if you've got big seeds, you can cut them up into pieces to aid the drying. And then we just calculate the mean dry weight and the percentage moisture content. If the dry weight's less than 20 milligrams, then your seeds are likely to be desiccation tolerant. If your moisture content's less than 20%, they're also likely to be desiccation tolerant. Okay, so if doing that doesn't give you an answer to how your seed's likely to respond to storage, then you can go to this next step, which is a little bit more complicated, and this is assessing the seed coat ratio and another value called the potential for desiccation sensitivity, or PDS for short. So for this one, you separate the seed coat and any other coverings from the embryo, you dry them separately, and then you calculate the ratio of the dry weight of the seed coat to the weight of the whole seed. And then you can throw that into a formula to calculate PDS. And if that doesn't give you an answer, then you can have a good look at the dispersal unit and the seed embryo. So anything that's got a woody endocarp, we found it's likely to be desiccation sensitive or only partially desiccation tolerant. If it's got a very green embryo, we found it's likely to be desiccation sensitive. And if you don't get any clear outcome from those, then it's back to the drawing board and you need to test germination while the seeds are fresh and then after drying. So what does that mean for land care projects? So if you do have a seed that's sensitive to drying, you need to germinate it while it's fresh. You can't really store it. You might be able to store it moist for a year, up to a year, depending on the species, but generally speaking, you need to sow the seed while it's fresh. And what you can do instead of storing seeds is store seedlings, and you can keep them in low growth by reducing the nutrients or keeping them under light shade. And depending on the species, again, they might survive for 1 to 3 years that way. And some example genera for that are Acmina smithii, which you have growing down in Victoria, and Eliocarpus species. Okay, so that takes care of the desiccation sensitivity aspect of storing seeds. Then the next part is how will they respond to storage at -20. And unfortunately, we discovered kind of by accident that a lot of the rainforest species that we were tolerant of drying and we put into storage at -20 degrees actually did really poorly at that temperature. And you can see this one in the middle here, Rhodamnia maydeniana. We'll go and take a closer look at that shortly. But that was basically reduced. Germination was reduced down to 0 within the space of a couple of years. So that was a little bit shocking. And to look into why that was the case, we started using thermal analysis. And this is a really cool piece of machinery called differential scanning calorimeter. And we can put a sample of seed into there on one side and a reference sample on the other side that has nothing in it. And we lower the temperature down to -150 degrees and then raise the temperature up again. And the machine records any changes in energy that occur as the seed is cooling and thawing. And then we have a look at the output, which prints out on a chart. And we look for major thermal events that are occurring around -20 degrees, which is our storage temperature, and temperatures where there aren't any energy changes at all. So here's an example. This is for Rhodamnia maydeniana, which is a rainforest tree. This is unfortunately very badly affected by myrtle rust and it's not producing seed in the wild anymore, and very short-lived in storage at -20 degrees. This is the output. On the bottom line, you can see what's happening as the seeds are cooling. And then on the top line, you can see what's happening as they're warming. And this point here is our normal storage temperature. And you can see this major melting transition that's occurring around the temperature that we're storing the seeds. So we thought, okay, well, maybe that's the problem. Maybe the lipids inside the seeds are unstable, or they're freezing and thawing in a way that makes the seed less viable when they're stored at that temperature for any length of time. So just for comparison, we have Syncarpia glomulifera, which is a tree from rainforest onwards chlorophyll forest. And that species we found so far has survived quite well in storage for 10 to 15 years. And this is the warming curve for that species. Again, this is what happens at -20 degrees, our normal storage temperature, and you can see there's not much happening at all compared to the Rhodamnia maydeniana seeds. So when we were looking at this, we thought, okay, maybe the storage temperature is the problem rather than the seeds as such. So we designed a few experiments to test the seeds at different storage temperatures and with different levels of moisture content. And the storage experiments were validating what we were seeing with the thermal analysis. So this is Rhodamnia maydeniana again. And this is what happened when we stored it at -20 degrees for just 12 months. And we had much better survival at either 4 degrees or -5 degrees. The problem with storage at 4 degrees, of course, is that eventually your oils can go rancid, but -5 degrees is probably not going to be applicable to all species, but it was really useful for this one and for several of the other species that we've tested so far. So what does freezing sensitivity mean for land care projects? Well, I don't know how many land care groups will actually store seeds at -20 degrees. That's actually more for long-term seed conservation. But it's good news for you because if the seed can be dried, then it can be stored in a fridge at 4 degrees. The storage life ranges from a few years to a few decades, of course, depending on the species, but they can store quite well in the fridge. So examples in this category are Ceratopetalum apetalum and Morinda jasminoides, which you might not be familiar with because they're from rainforest up here, but I didn't have any data on species from Victoria. Okay, so can rainforest seeds be banked? Many can. The long-term storage requires research on the best moisture content and storage temperature. But short-term storage can be accomplished just by drying the seeds in an air-conditioned room and storing them in the fridge. So if you have seeds that are desiccation tolerant and you want to maximise their storage life, here are a few tips. If you can, it's much better to collect directly from the plant rather than from the ground because the seeds deteriorate more quickly as soon as they touch the ground. They get invaded by fungi, bacteria, all sorts of microbes, and they're more prone to deteriorating quickly in storage. So if you can bag the developing fruit and collect the seed that way. That works quite well for Nothofagus species if you can climb the trees well enough to actually get them. But if you can at least sort of catch the seeds in a net rather than picking them up from the ground, they'll last longer in storage. I'll just say that has no bearing on the germination. Your seeds might still germinate fresh very well if you collect them from the forest floor. This is just in terms of storage. Check your seed quality with a cut test. So cut a subsample open with secateurs or nail clippers or whatever else you've got on hand. Make sure that the seeds are filled and that the embryo inside looks healthy. So if the seeds are empty or they're discoloured, then there's no point in banking them because you're not going to be able to germinate them when you pull them back out. And the last tip is to dry and store the seeds quickly. So try and extract the seed from the fruit within a week or two of collection and try to get them into storage after you've dried them for no more than a month. And the faster you can get them dry into storage, the longer they're going to last in storage. So what can you expect in Victorian rainforest? So I had a nice list of species that Abby provided and I checked up which ones were rainforest species through Vic Rainforest, and I've pulled out these ones that have actually been tested for desiccation tolerance and they are tolerant. And then we have a list here of those that are likely to be desiccation tolerant just based on their seed size or the behaviour of other species in the same genus that we've tested here. So quite a few of your species, actually most of the ones that I had on my list were actually bankable. The ones that you're going to have trouble with are Achomenos smithii, of course, is desiccation sensitive. So you won't be able to store that one at all. And then ones that we don't know for sure, but I suspect are likely to be based on other species. We have Coprosma quadrifera. I can't pronounce that, quadrifera. We just tested 3 Coprosma species from Lord Howe Island and we got very different results from them. So the bigger seeds were desiccation sensitive. The smallest seed wasn't. So this one is just one of those ones that you're just going to have to test and see. Elaeocarpus holopetalus and Elaeocarpus reticulatus are likely to be desiccation sensitive based on other Elaeocarpus species we've looked at. And then there's Rapania howittiana. We've only tested one species in this genus and it was desiccation sensitive. So this one might be, might not be, but it's one to keep an eye on. Okay, well, that's all I've got for you for the moment until we go to question time. I just want to say a big thank you to past and present team members of the Rainforest Project, and also the very kind people who've provided us with funding over the years, from Arcadia Fund and HSBC Bank to private donations from members of the Foundation and Friends of the Botanic Gardens. Thank you very much.
Thanks, Karen. I'll jump in with one of my questions first, if that's all right with everyone. I was just wondering, for those who don't know, and I know we don't practice this at Seeding Victoria, but how do you store seeds moist? If that question makes sense. What's moist storage?
Yeah, it totally does. Clean them up as best you can. Put them into a big bag and put in some paper toweling. And you need to open the bag periodically to let out any gases that accumulate, and you just need to try and soak up any moisture as it's generated. So yeah, paper toweling can help soak up moisture, but you can store them for a while. I had one student who was working on bunya pine, which are, have really big seeds, this big. And they lasted for up to 4 years, just stored in the fridge in that way. So it's going to depend on the species, how long they'll actually last. But yeah, it is one way that you can get around that desiccation sensitivity.
That's amazing. I might hand over to Abby and the Shrub Club team really quickly and see if they have some questions for you too.
Awesome. Yep. Thanks, Elle. Thanks, Karen. That was so fascinating. Well, I wanted to ask a question that related to Elle's. You also mentioned storing seedlings, and I kind of missed the nuance of that. So can you explain how, is that for collecting seed off later, like growing on, or is it just actually storing seedlings?
Yeah, it's a strange term, isn't it? It's basically just germinating your seeds and then keeping them small. So you're depriving them of nutrients and depriving them of light, so they don't grow too big, which means that you can keep them in your forestry tubes for longer before you plant them out. So yeah, some species you can keep that way for 2 to 3 years. Some species might only be 1 year, but it's one way of dealing with those desiccation sensitive species that you can't store very well.
Yeah, for sure.
So like, rather than storing the seed, just storing the seedling, just smaller.
Yeah.
So grow more when you have seed, and then stunt their growth so you can spread it over a few years. Yeah, which is sort of what we did this last year. We had a freak season for Myrtle Beach, and we had thousands come up. So we potted as many as we could, which was over 1,000. So we've potted some on, but we've been trialing different things of placing them in shade and light and just trying to work out which ones are growing fastest that we need to plan out this year, and which ones we can slow down a bit and spread over the next couple of years.
Yeah, exactly.
Yeah.
So your Myrtle Beach also, you should be able to store.
We haven't had, interesting that you say collect from the tree. As you know, it's a massive tree. So we go out like after storms, and the way we've collected Myrtle Beach is just sweeping up all the forest floor sweepings. And I'm gathering that there's something in there. It's not just the moisture. I think some of the seeds are probably already germinating when we collect it, but I was wondering if there's some mycorrhizal association that's accelerating germination or allowing germination. And we have dried out that leaf litter before and stored it in the fridge. And to my knowledge, it hasn't germinated as well as when we've stored it, just when we've sown it fresh. So yeah, how does that potential for fungal associations interact with their storing capacity?
My guess is it will have more to do with the initiation of germination. So Nothofagus species, if they're going to germinate, will germinate really quickly. The ones that we tried here will start germinating within a week or two. So if they've already been on the forest floor for a couple of weeks before you get a chance to get those sweepings, then the germination process has already been initiated, and they won't survive drying out.
Yeah. interestingly, the ones we collected this year, I thought because it's been such a different season with when everything's been ripe, it's been very late. And the floor sweepings we collected this year, we got 3 germinants after a week or so. And I was like, okay, well, lucky we got a lot last year. That was in the end of January. And
Yeah.
I just went into the polytunnel yesterday and found that there's hundreds or probably tens that are coming up now. So, you know, it's been 3 months and suddenly they've decided, I don't know if it's this weather, it's warm.
Oh, okay, so maybe they were a bit dormant.
Yeah.
I haven't got a definitive answer for you on that, Abby, but it's interesting.
And I guess something, so I'm just going to keep going with questions while I can't see if we've got some queued up, but feel free to interrupt Tani or Anna if there is. Something we notice with rainforest plants is that when we first sow them, they won't come up, and we will leave them out. We have this area for like our rainforest and slow germinants that we can keep an eye on them, but they're sort of down the end because we just don't understand what they do. But some of them, like, you know, we'll leave it there and a year later, they just suddenly germinate. And yeah, I'm wondering what is it that's happening with those seeds that they can remain dormant even when it's the right time of year, and then come up a couple of years, you know, a year or 2 later.
Oh, that's the eternal question, Abby. We've come across quite a few species like that, and yeah, and you'll sow them, leave them, go and check on them once a month, and eventually something will come up, and that's just their way. They're geared up to germinate in the wild. They're geared up to spread out their germination. Overcoming that dormancy, you can do it if you have the right conditions and if you have enough seeds to do a whole bunch of experiments to get the right sequence of temperature treatments or the right chemical treatments that you need to apply, but you need a lot of seeds to try and nut it out sometimes. I think that your approach is that you're using is probably the best way about it. Just put them in and see how long they take to come out. One thing they do use up at Firewheel Nursery is what they call dry composting, and they will put the seeds into just some potting mix and just keep turning them over. The potting mix is just a little bit moist, and they just look at them periodically. When it starts to put out a radical, then they'll sow them.
Right.
But I think that's, yeah.
So they turn the compost?
A little bit, not regularly, you know, just stick your hand in and turn it over a few times and then, yeah.
Wow, that's really interesting. Yeah.
But we have found that with, one of my colleagues was working on I think it was a Xeria species, or was it Garnia? And so she did a soil burial experiment and she found that it was cycling through dormancy within the soil burial experiment. So no germination after 3 months, nothing after 6 months, and then it germinated well after 12 months and then went back into dormancy and then didn't germinate again for the next batch that was pulled out. So yeah, seeds have got some fascinating mechanisms for surviving.
And was that Garnia, did you say?
I can't remember whether it was Garnia. Yes, it was Garnia.
Okay.
Garnia Siberiana.
Oh, yeah, we've had good germination with Garnia, but it's
we didn't last year.
We didn't last year. It's hit and miss, and we collect a lot of seed because it's easy to collect. So I think our germination is probably quite low. We just have millions of seed. Yeah, how interesting. And what about you had Pittosporum undulatum on the list? Down here we have Pittosporum bicolor, which it actually crosses with undulatum. Like undulatum's been planted out as a, I think, fodder. Is it fodder or shade for animals?
Mostly.
Yeah, it's a good paddock tree and shelter and everything, but being a really delicious berry, it gets moved around the otways, and it actually is crossing with Pittosporum bicolor. So we get these hybrids, and which is, yeah, I think one of the probably the biggest risks threats to Pittosporum bicolor. So we do try to collect a lot of bicolor, and we see around the Otways these little regurgitated pellets from, I think they must be bowerbirds or
Or like, corals, I think.
Carolons.
Yeah.
Yeah. So they're obviously going through some nice stomach acid before they germinate, and they have that really sticky seed coat on them, which we scrub it with sand and detergent. And what was your latest thing,
We
Chris?
didn't have any degreaser.
Degreaser.
Oh yeah.
Going hard on these seeds. And we have quite good germination, but it does take like a year, and you think nothing's happening, and then they'll all pop up. But yeah, so that is a recalcitrant seed, is it?
Well, no, not necessarily. So I thought that all Pittosporums were pretty much desiccation tolerant until we got some of those ones from the tropical cloud forests and found a couple that were desiccation sensitive. So yeah, I would say the majority of them are okay and desiccation tolerant, but there's just enough variation in there to make me think it's a good idea to test it to make sure you know for sure.
Yeah, so if it's desiccation tolerant, but all the literature that we've read says sow it fresh, they can still be desiccation tolerant, but their germination's reduced, or
yeah, it might be that drying puts them into dormancy, which just means that they take longer.
Yeah.
But a good one to play with. It would be actually, if you come across some more of those regurgitated seeds, it might be fun to sow those alongside some freshly collected ones and see if there's any difference.
Yeah, no, definitely. Yeah, no, we do collect. We do collect all fox poo, all kinds of things. Seeds have been through because, yeah, usually they have really good germination.
I met a guy who collected cassowary poo in Queensland once, and he told me he sowed all the poo over these seedling flats, and he ended up with something like 100 different rainforest species.
Wow.
Yeah. I think I saw a program on that once of a seed group up in the Daintree that were collecting cassowary poo to germinate seeds, which is very cool.
Yeah, we got given a chunk of poo from an emu. It's a weird sentence to say in any other conversation, but yeah, it had some heath seed in it, and we've always been wanting to like try it and see what that will come out as, how well that will germinate. So yeah,
That'd be a very cool experiment.
Definitely worth a try.
yeah.
All right. We have a couple of questions here. Oh, sorry, Abby, do you?
No, I just hadn't. Why don't you read the other questions out, and then I can come back to us.
Sure. All right. There's one here that Ellie will respond, but I guess, Karen, there's one here for you. Should you keep the paper towel moist when you put the seeds in the fridge, in particular the Copromosa quadrifidi?
No, put a dry paper towel in, because the paper towel is just to soak up the moisture that's generated by storing the seeds when they're fresh.
Yep, thank you.
So there's another one here. Do native grasses follow the same principles, or are they generally easier to store? At the seed bank, we have a lot of grass species, and we just store them dry, both in our storage fridges and some just in our shed at room temperature. And I'm sure Abby is similar. But I'd be interested to know if there are any grass species, Karen, that are responsive or recalcitrant. We haven't come across any that we've had trouble germinating in our area of Victoria, but it didn't seem like there was a lot of grasses on your list. But to be fair, I don't know all the genera in your herb list that you had in your presentation, so I'd be interested in grasses as well.
We hadn't tested a lot of herbs. Sorry, my battery is just going numb, even though it's supposed to be plugged in. The grasses are generally fine to store, to dry and store. Yeah, I've not had any problem with them at all. And most of the herb species that we've worked with so far, I haven't done much with grasses, but we have used a fair bit within the seed bank. And the herb species are usually fine as well.
There's also a few more. Questions are definitely coming in at the moment. So Emma Stone is saying that they are using a dehumidifier inside a custom-made drying cabinet to assist with drying. However, they have concerns about the increase in temperature that the dehumidifier generates. Are there any concerns about temperature in drying?
Yes. If you can dry them at cool temperatures, it's much better for them. So usually room temperature in an air-conditioned room is pretty good. We tend to dry our seeds at 15 degrees Celsius, but if you're drying them at, say, 35 to 40 degrees, then you're accelerating the deterioration, the aging process. So it's not so good for long-term storage.
Thanks, Karen. Now, I guess one last one before we go to Abby again. From Mike, the dormancy may turn on and off due to a species having a germination window. Example, maybe a winter germinate. If sown in spring, seed won't germinate till next winter. Then turn off, then turn on again the following window. This has happened with Pittosporum bicolor, Nematoplepis squamia, and Xeria arborescens, and a few others. So sorry for the complicated question you say, and sorry about my really horrible spelling.
No, that's exactly right. You get some species that have seasonal cycling of their dormancy. Absolutely.
Thanks, Mike.
Could I just ask really quickly? For those of us who are new to the seed game, when you talk about lipids inside a seed, what does that mean and what does it do? So just kind of a bit of a context on what we're drying, if that makes sense, and what we're not drying.
Yeah, so lipids are used in seeds for storage, so for energy storage. So the seeds can draw on that energy storage in the same way that they draw on starch to help them to germinate. If you can get seeds that have a high lipid content, and macadamia is one of them, it's got like the seed is 70 to 80% oil. The oils will respond differently to temperature, to lowering the temperature or to warm temperatures, depending on the makeup of the fatty acids within those lipids. It's a complicated topic, but basically, if you've got a high lipid content in your seeds, then there's a chance that you're going to have problems with storing that seed in the freezer, and you might find that it tends to go rancid in storage at 4 degrees over time.
Thanks, Karen.
Thanks, Sally. One last one, Abby, sorry. So when you see, Claire is asking, with the seed you had to crack with a vice, how would this be replicated in nature? Do you know?
I think it would just be aging of the seed over time. And just creating that gap. I know if you can recall, some seeds have a nice little sort of suture around the outside. That's where the cracking works best, if you sort of go with that. But if you left it in the wild, then it would just open up naturally itself over time as the connections between those two halves deteriorate.
Thanks, Karen. Abby, do you want to continue?
Yeah.
Thank you.
I had one more question, and then Tony also has a question. So I'm just interested in why the trees have a higher sensitivity to desiccation than shrubs and the smaller shrubs and herbaceous plants and climbers. And then related to that, you mentioned that it's always better to pick seed directly from the trees. And there are a couple of species I'm thinking of, particularly Hedycaria angustifolia, which is a austral mulberry that we always collect from the ground because we find those seeds have better germination, they're much riper. But and the ones left on, like they tend to fall off the tree as soon as they're kind of ripe. You don't generally find nice ripe ones on the tree. So is there, yeah, how would that fit in the idea of like picking from the tree, but they're not necessarily
Yeah.
the right ones?
Yeah, that's always tricky to find the exact right moment where it's hit that peak maturity, and catch it before it drops. You can do that if you can bag the branches to catch the fruit, or if you can string a net underneath the tree to catch the fruit rather than letting it fall on the ground. That's one way to do it. Yeah, and I'm sure germination is fine if you're collecting from the ground. I know we do it when we've got no choice, but if you are picking up from the ground, just try and pick the most freshly fallen ones. So
Okay.
look for the ones that don't have any evidence of the fruit already deteriorating or covered in fungi.
Yeah. Okay. And why is it, out of interest, that the trees, do you know, like why they have a higher sensitivity to desiccation?
I can speculate. I'm thinking maybe it's because those taller trees have that canopy underneath them. So the seeds are naturally dropping into shaded conditions where they're going to germinate. The seed's going to be moist. And that's just what they're geared up to. That's my best explanation for the moment.
Sounds like a good one. Tony has a question about orchids. I don't know if you have looked into them very much, but he found what was the orchid you found yesterday?
Butterfly orchid.
A beautiful epiphytic butterfly orchid yesterday, and is really interested in propagating them.
So first of all, when you collect, are you allowed to collect orchid plants or seeds?
If you have a license.
And do you have to have a special license or just a?
I'm not sure what the licensing situation is in Victoria, but we're only allowed to collect under license.
Yeah, so I can kind of help with that a little bit. If you want to collect actual pieces of the orchid, you'll have to apply for a specific permit from DECA, just saying that you want to collect actual pieces of a plant as well as seed. And that's both in that same permit section on the DECA webpage. And you just need to say that you want to collect, portions of the plant as well, actual plant matter. Yeah. Don't know if that helped.
Yeah. So that includes if you did, and I have never tried to propagate orchids by seed. I have no idea what that process looks like, but that permit is for seed collecting also.
You would just have to mention both,
Yeah.
portion of seeds, or portion of plant and seed matter. So, yeah.
So, Karen, how do you know about collecting seeds from orchids?
I've worked with terrestrial orchids, but I haven't done much with the epiphytes. For the terrestrial orchids, we actually will go out and we'll hand pollinate and hand cross pollinate between individuals, and then we'll put a bag over the top of the pollinated flower and we'll go back and collect them. They take about 6 weeks to ripen, and once the pod starts to open up and dehiss, then that's a good time to collect them. The epiphytes, from what I've read, they take much longer for the seed pod to develop, but you can collect it when it's green. So you can collect it when it's green, and then what you do is you flame sterilize it and sow the seed onto nutrient media. So that's one way that you can grow them, or otherwise you just have to wait until it starts to dehiss and keep an eye on it. So if hopefully it's nearby and you can just watch it and see how it develops and see how long it takes.
There's some really good sections in the Australian germplasm strategy. I think I sent that around earlier, Abby. It's an online resource. I'll put the link in the chat or we'll supply it. But it's a big document that covers germinate. Yes, that's the one. Yay! Number two. But there's a lot of good sections in that in terms of orchid propagation and germination and that sort of stuff.
Excellent.
Ooh, sorry, I had to move because the PowerPoint wasn't working where I was. So I'm now at my desk in the middle of the office and everybody's listening in.
It's like your own.
We do have a couple more questions from online. One from Cherish. Hi, Cherish. Are seeds like macadamia with high lipid content generally DS? And oh, it just jumped up. I just lost it.
Sorry, that was me. I moved it to the answered question.
Oh, okay. Yep, here it is.
You have it?
Are seeds like macadamia with high lipid content generally DS, and is this covered in the moisture content predictor?
No, quite a few of the species seeds that we've looked at so far that do have a high lipid content tolerated drying. They just didn't tolerate freezing.
Okay, great.
Yeah, and the moisture content, the higher the lipid content, the lower your moisture content is going to be at maturity. Yeah, how it affects the predictor, that's a good question, actually. I'll have to think about that one.
We'll get back to you, Cherish. And just one last comment from Sharon Coulter. Hi, Sharon. We've had great success with germination of Coprosma quadrifida by cool storing fresh berries for 2 weeks, sowing fresh and keeping trays under benches in houses in shade. So that's good for us to know too. So thanks, Sharon. Spread the knowledge.
Can you repeat it? Was cool store for 2 weeks, so fresh.
It was cool storing fresh berries for 2 weeks, sowing fresh, and then keeping trays under the benches in the shade.
Wow. Okay.
In houses, yeah.
And
In shade.
our advice that we've had is that some areas, some provinces and some communities Prosma have excellent germination and others just are rubbish. So I don't know what's going on there, but we're going with that theory. Yeah. Yeah.
How big is the seed? Is it just a small one? I haven't come across the species before.
Yeah, it's very little, but it's really prolific, the plant. Like it'll just be covered in seed and birds love it. And it's one of those plants, like I think you find this with a lot of rainforest plants, like leave them to their own devices and they pop up everywhere, like more than you want them to, but try to grow them in a nursery and they're impossible. So yeah, it's amazing that some plants don't have seed that is as viable as others.
Yeah.
Getting back to the macadamias.
Oh yeah, that was my favourite topic.
No, actually, I've got a macadamia down here, a southern one, and it's producing nuts, and this is in the Otway, so a long way away from where it's originate.
Yeah.
The seeds take the outer shell comes off, then you've got that really hard shell, and it slowly, over a few months, under the tree, it breaks down and out comes a little root. So it might be the fact that it's under the tree that helps it. When it rolls away from the tree, it doesn't seem to do that.
Oh, right. Okay. Yeah, maybe it dries out when it rolls away from the tree.
No,
They germinate within about a month in the lab. So yeah, we've not had a problem germinating the fresh seeds. They're pretty good.
Right. Yeah.
Yeah, and they smell delicious when you dry them in the oven.
Do they?
I bet.
We've been drying Banksias this morning in the oven and commenting on how delicious they smell, like chocolate brownies.
Oh, nice.
Yeah.
Okay, Karen, I've got another question here for you from Emma. On the type of scales or equipment to assist with determining moisture content. What are those?
On the type of scales?
Type of scales or equipment? What type of equipment?
Okay. We use a digital balance, which means that we can use fairly small amounts of seed. It's got measures up to 4 decimal places, but you could do it on just an ordinary food balance if you have enough seeds to work with. Yeah, and we just measure them when they're fresh, pop them in the oven, measure them again when you take them out of the oven. But after you've taken them out of the oven, you need to dry them over in a dry environment, like say over silica gel or over rice or something like that, so that they don't take up moisture, because once they're dried out fully, then they'll take up moisture from the atmosphere really quickly before you can weigh them.
Thanks, Karen.
Mm.
So I'm not sure about what do you think about it, but I think we probably are very close to wrapping up tonight's webinar. We do actually have one more question from Tani. Tani, do you want to go ahead and
Oh, I get to be lucky last. Amazing.
yes.
Abby, at the very, very start of your presentation, you mentioned there's ethical considerations with collecting seed. I wondered if you have any advice for those that may want to start collecting seed but don't want to disrupt the natural systems it comes from.
The best advice, I think, and Elle can speak to this too, I'm sure, is like looking at the Flora Bank guidelines for seed
Yes.
collecting. They're really the go-to guide for how to collect seed ethically. And yeah, just for those who didn't understand what that means, I guess it's about understanding your population and how much you're taking from it. So in most situations, not more than 10%. And understanding, what a population is, where it starts and ends, and assessing the health of the plant and accurately recording all the data around the provenance of it, how healthy the population was, where it was, and so on. So
yeah, and more to that as well as 10% of a population, 10% off a certain individual. And to make sure that you do have a permit before collecting if you're collecting on public land. And also really take into consideration when you're in the environment how that population is being used by what's there other than humans. When we go to a place, if we're seeing that wildlife are currently using it, we move on to the next spot. We don't want to interrupt. And just to keep that in mind when you are collecting as well. So if you're collecting 10%, you also want to be mindful to leave seed there for ecological processes, for creatures that eat seed, for natural regeneration of the plant, and for natural seed banking of the plant, so that there is regeneration as well after things like fire or flooding, so that we're not just taking everything from an environment. There's a lot of conversations around this at the moment because there has been more things that we need to consider, and obviously the more we learn, the more we need to integrate that into our collection practices. And so I would also recommend looking at the species you have in your area and seeing what does predate on seed, what doesn't predate on seed, how much is left there, how much is a food supply, all those sorts of things. There's a lot to go into it, and just be mindful that if you're going there and collecting 10% today, there's currently nothing that tells us that someone wasn't there yesterday collecting 10% and there's not someone there tomorrow collecting 10%. So just be really mindful of only collecting what you really need. If you're doing a project that has, say, 200 trees involved, you only need a little bit of seed, especially from like a eucalypt or something. You don't need to be collecting masses and masses of it for every project. I think just going in there with each objective in mind and really mindful of your local ecosystem, and also just mindful of all those traditional practices as well. There's a lot of things that go into it. Reach out to your local TOs and have a chat with them as well before collecting seed. I think I could go on for ages about that topic, sorry, but I'll just wind it up there. But if you do have any other questions around that, please feel free to contact us at Seeding Victoria at info@seedbank.com.au, and we'll happily provide you with more resources around ethical seed collection.
Thanks, Ellie, sorry. So I think we probably good to terminate our webinar. I'm not sure if Karen and Abby, if you have something to say about tonight's, I guess we all learned so much from Karen. I hope you enjoyed being with us tonight, Karen. I'm sure everyone really loved having you in Victoria online. Abby, do you want to say something about today?
Just very grateful to you, Karen, and for Elle for teeing this up. And we will definitely be contacting you again, Karen, for more info. But yeah, I think it's been really informative today. So thank you, and thanks to Anna and Lankevic for hosting.
Yeah, and I'd just like to say thank you again to everyone as well, especially Karen. Really looking forward to staying in touch and seeing what we can develop from here on out. And also thank you to everyone who came along. I'm really happy to see that this was a topic of interest. And I think the more we know about seed ecology, the more people are interested, and it's really great to see. So thanks to everyone in the Landcare community as well.
All right. Thank you, Ali, and thanks to you, and thanks for enabling this collaboration and getting this webinar going, which will be again available in our website probably next week or tomorrow. So hope you have a good afternoon and a good weekend, and I'll see you all at our next webinar.
Thanks,
Bye-bye.
everyone.
Thank you.
Thank you. Bye.